Hello everyone, this is Dr. N.G. Pravina, working as Associate Professor in the Department of ECE at R.M.K College of Engineering and Technology. In this video lecture, we are going to discuss about the engineering as social experimentation. What are the topics I like to cover under this discussion is engineering as experimentation and how engineers are responsible experimenters. So engineering as experimentation. See, whatever the components we design, right, it will not be developed as a full-fledged product. Almost all the products, whatever we design, it will be based upon so many trials. We do designing. If we are not satisfied in designing, then we do redesigning. Then we give it to a testing department. We test the quality and the property of that particular product. Then if at all, if everything was satisfied, then it will be launched as a product. So it involves, before a product is available in the market, this process is a very tedious and it involves so many assumptions, so many trials, redesign, design, then testing. It involves many materials and experiments, and by the test data, by analyzing the test data, we do redesign, then we retest. It is an iterative process because based upon the feedback received on each and every stage, we go back to the initial process, then we do redesign. So engineering as experimentation is an iterative process. So what is meant by that? Initially we design, several designs we do. After designing, it will be given to a fabrication, assembly and physical test simulation. So it is applied to a fabrication section, then we do assembly, then we do physical test, then we do simulation. If that particular product satisfies all the things, it will move to the next level. There we create a prototype, or we have a pilot model, or we do a model study. Then it will be given to final design, then to manufacture, then to a field study. If at all, if any stage, if you are not satisfied with the process, or if the results are not satisfied, then we can avail a periodic feedback on each and every stage, thereby we do a redesign. That is why we say engineering as an iterative, interactive process and an iterative process. What are the differences and similarities and between engineering experiments versus standard experiments? Here I have listed out some similarities and contrast between these two. There are partial ignorance, uncertainty, continuous monitoring, learning from the past, or the similarities between the engineering experiments and standard experiments. And there are few contrasts: experimental control, human touch, informed consent, knowledge gained. What is meant by a partial ignorance? See, while we design a project, while we design a product, sometimes we are not certain about the model what we are planning to do, right? Why? Because the behavior of the material which we are planned to complete the experiment will not be uncertain. It will change based upon the time, or on the temperature, or on the other conditions. So, and moreover, when we go for this, we neglect, for time being, we neglect this thing, and we start to do the project. But when we are not ended up with the good results, then it will create the failure and it will create stress upon the engineers. Then uncertainty. What is meant by an uncertainty? We know that we get the outcome when we do a project. Okay, we know that we are sure that we get a final outcome, which is always uncertain. Why? Because we may sometimes, right, the side effects and the unsafe operation all may occur, thereby it will result, okay, the uncertainty. What are the unexpected risks we can come across? Say for example, when we construct the storage dam, there may be a undue seepage, or when we built an atomic power plant, there may be a problem of leakage of nuclear radiation, or we may while we use a soft drink bottle or any storage foods, we are not sure about the presence of pesticides, but they will add pesticides. So these are the uncertainties which may occur, that may lead to the health issues of the human being. So what is by continuous monitoring? Whatever the product we design, right, we have to do a continuous monitoring on that. So we have to gain the knowledge of what we are going to do and how we are going to do after executing the project as an experimentation. If at all, if that project, or if that output, or if that product is not going to yield properly, then what happens? We have to come back to the initial stage, then we have to do the entire process once again. What is meant by learning from the past? So learning from the past is nothing but, as all of us know, that while we start up with a project, while we start up with an experimentation, if you are not yielding a good result, then we alter the components, or we alter the materials. Then after a period of time, if you are going to do another project, what we do, we will get a lesson from the past. So based upon our experience, we will be very cautious and we plan according to that. Here a simple example has been given here. As all of us know that at Titanic, okay, here in Titanic, what happened? The problem is, it can accommodate only an actual passengers of 2,227. But what they did, due to emergency situations, due to some problems, they have allowed a passengers of 3,547. So what happened? That is a big problem. It was created in the past story. So after that, based on that, okay, nowadays what they are doing, they are doing so many precautionary methods to overcome all those problems. So here, whatever the lessons we learn, right, those lessons, okay, we can apply, okay, for our future models. Say for example, hydraulic system, 3 Mile Island, a very tragedy that happened quite long back in the year of 1979. So from based on this, okay, we are able to find out the any malfunctioning in any walls or gauges or whatever it is. So we are very cautious about the power plants. So these are the lessons we have learned from our past. And what are the contrast we have? We have an experimental control. What is meant by an experimental control? Say for example, in standard experiments, okay, we will be studying the experiments randomly, okay, with two groups of peoples. One is group A, they'll be giving some special treatment. Another one is group B, they are called as a control group. They will not be given any treatment, okay, they will not be undergone any treatment, but they will be placed in the same environment as what, group A. So you can apply this in the process of finding the medicines. So what happens? Group A will be going for special treatment, and group B will not undergo anything, but they'll be calling as a control group. So but in engineering, you cannot apply this type of concept. So here, all the products, whatever we choose, the consumers or the clients, whatever we choose, okay, so what they will do, they will pick randomly the products, okay, from the participants, and they will go for random sampling and they will take the survey. So in standard experiments, this groupism is applicable, but in the engineering experiments, experimental control is not possible. Human touch. Human touch is nothing but, as all of us know that engineering experiments, whatever we do, constructing a dam or constructing a power plant, okay, all depends upon the human souls. Why? Because we have so many expectations on that. So what we do, it will have their needs. Based on the needs, based on their views, based on their expectations, we do the engineering experiments. So even you may not be disagreed, okay, with this point, but the quality engineers and managers, while they assign this type of projects, okay, they will be considering this human touch. and informed consent. So what is meant by informed consent? Informed consent is nothing but while we do an engineering experiments, right? So we may have some medical experimentation can be done on the human being. So suppose if a human was chosen, okay, for doing a medical experimentation, he has to be informed well what he is and what is going to underwent. So he has to be very clearly, he has to understand what are the medical practices he is undergoing, undergoing, and what are the moral and legal rights he can claim and all those things. So the informed consent has basically two elements. One is called knowledge, the other one is voluntariness. What is meant by knowledge? Here in this, the humans should provide with all the information, right, to take the decision whether to participate or not. If you are not providing any knowledge, if you are blindly telling a person to go for this experimentation, he may agree, but if there are any consequences, then everybody should suffer. So what happens, we have to provide the complete knowledge about the experimentation to the human being. And the second one is the voluntariness. What is meant by that? Here the human subject, whatever we are preferring, he should give his willingness, okay, to act as an human model, right? You cannot force them, or you cannot do any fraud, or you cannot do any thing to that human being. So he has to come forward, okay, voluntarily to act as a human subject. So for valid, okay, consent, okay, consent or should be voluntary. You cannot apply that, okay, through a force. All the relevant informations has to be presented to that human subject in an understandable form, and the consenter, that is the human being, human subject, okay, has to process the information and he has to make the decision. Then the subject content, okay, should not be offered in a proxy, okay, it should not be acted as a proxy. What is the knowledge gained? Okay, this is the another contrast, okay, we are going to discuss with respect to social experimentation and agenda experimentation. What is the knowledge gained, okay, we can have here? Not much of here. When we do the engineering experiments, right, we cannot apply a very new knowledge. But while we do a scientific experiments, okay, we can have many new knowledge, we can create a new products. And the engineering experiments, okay, whatever we design, it can be adequacy. You should apply, you should find out whether the design has an adequacy, or whether the parameters what we are doing for designing purpose is having a stability, and whether the outcomes will be able to satisfy the actual field environment. So these are the things we have to decide. And moreover, from the models, okay, when we get the models from the laboratory, it has to be checked in the real time environment, okay, in order to satisfy the outcomes. The next topic what we are going to discuss is about the engineers as responsible experiments. How engineers will act as a responsible experimenter, how they can be, right? So here we are going to discuss a few points under this topic. How an engineer should be a responsible experimenter. First, you should have some commitment. Without commitment, you cannot be a responsible experimenter, right? And moreover, the engineer will have an highest responsibility in the society. Why? Because he has to monitor the project, and he should identify the risk, and if there is any risk, he should inform the client and the public with what actually the facts are. He has to disclose all the problems whatever the particular project is facing. If he should have his responsibilities. So he should have a very good high commitment. And moreover, he should be aware of this experiment. If he may start with an experiment, he may end up, but if he is not aware of it, you don't know the consequence. So he should have been highly committed, and he should have an awareness of the complete project, and he has to monitor the side effects also. And moreover, he has to involve, okay, unrestricted free personal involvement in all steps, okay, has to be carried out by the engineer. and he has to be accountable. He should not simply blame others when there is any negative outcomes, or when there is any negative results comes. He should not simply say that I am not responsible. So he should be more accountable. Consciousness, so you should be very consciousness to all the problems whatever it arises. So you should have some moral values and responsibilities, and moreover you should have some skill and pull efforts, okay, to have an high balanced condition. And the engineer should always should have open eye. Open eye is not an open ear and open mind. It is not a physically they are speaking eye should be open or ear should be open or mind should be open. It is not that. You should have a moral vision, right? You should have a moral listening. You should have a moral reasoning. Whatever we say, right? You should not blindly, you should not follow it. You should think that problem, okay, in a moral manner. That is why the engineer should be very, very consciousness about its human values. The comprehensive perspective, whatever the work, okay, he is doing, whatever the project he is doing, whatever the product he is doing, he should have some comprehensive concepts. If he is not having comprehensive concepts, then it will not lead to a good end, okay. If the engineer should have a complete data of his work and ensure that it has to end morally. If he is not having his consciousness, or if the project or the product is having any problem, then it may result in a false claim. So you should understand the importance of the social impact or environmental impact of the product, and thereby he has to undergo this comprehensive perspective. Moral autonomy, what is meant by moral autonomy? Moral autonomy is nothing but he has to understand, okay, what is the actual problem, okay, he is facing, and he has to have a positive attitude in all the aspects, right? And moreover, you should have a great sense of personal involvement in one's work. See, if any work is going on, he should involve, okay, personally. Accountability, as I said you, accountability is nothing but he has to, whatever the negatives or whatever the problem arises, okay, due to this, right, he should have an accountable. He should not simply blame others. So he should be what, he should be responsible, he should be answerable, and he has to be more obligated, right? So if there is any problem comes, okay, he has to come back, okay, to that place, and he has to listen to the persons, okay, of or the employees who is working there. And you can see here, whenever whenever, okay, an engineer is doing anything, he will be what, he will be segregating the work, okay, into so many hierarchies and so many peoples. But what happen when any project comes, okay, when any problem comes, okay, what happens, he should not blame the particular team. So he has to take responsibility, he has to take accountability of whatever the shortcomings or whatever the problems he is facing. And here I have given some activity based learning. Hope you have enjoyed the class. So in this topic, in this discussion, I hope I made you clear what is the basic difference between an engineering experimentation and a social experimentation, and how engineers should be acted as a good experimenters. Thank you all.